Yes, welcome. I was going to go over my experience with using Doxygen and Fortran, but if there's any other questions before that, we can discuss whatever you have in mind. I see Mohammed, I think you emailed me earlier, right, about CGNS? Is this the same?
Yeah,
Okay,
yeah. Hi, Scott. So
hello.
I still have the same questions if you wanted me to ask them now.
Sure, go ahead, ask away.
Yeah. So the question is, you have that HDF compression branch. So that means the compression capability with the chunks and filters is not available for CGNS by default. It's just in that branch.
Right. Until we release it, the problem is we haven't got any feedback on it, especially for the parallel, because we were wondering how well the parallel compression works. Because I mean, general parallel compression in HDF5 is fairly new. And it hasn't seen we haven't got a lot of feedback for how the parallel compression scales. We were having issues in the past with the compression in HDF5 scaling at really large scales, but we haven't really got any feedback other than that. So that's why we kind of wanted to get feedback before we push it into the main feature branch or the main CGNS branch.
Okay, so that also means that even in HDF5, not CGNS, parallel compression. So the parallel compression might have issues, but what about serial compression?
Yeah, there should be no issues with serial compression.
So
The
when
same with
I noticed in the past, I was working before on a problem, and I noticed that okay, doing a chunking, we were not doing chunking very efficiently. We were using the full size of the array we are writing or the data set as a chunk size, but that was eating memory a lot. It was very large amount of memory being held and used by writing, and also time. So at that point, we changed it to simple, just simple data sets, and it improved a lot. But recently, I got to test in Python the H5Py and noticed that okay, compression still takes a lot of time compared to the simple data and maybe also memory, but it reduces the file size at least from 2 to 3 times. So the question, can we do the compression and chunking in HDF5 in serial without it hurting the performance so much? Is there a guidelines to choose the chunking sizes and compression levels so that we can have a balance between these?
I mean, in terms of compression levels, it's up to whatever compression tool you're using. Unfortunately, for chunk sizes, there's no hard, fast rule about what chunk size you can use. It's kind of, you just have to experiment with what is a good size. There's really no set. I mean, obviously you don't want too small. Have you been doing any of the talks that we've given on HDF5, tutorial introduction, stuff like that? Do you understand like the basic concepts in HDF5 of chunking and how
Yeah,
that,
I guess I think so. Yeah.
okay, so you do realize that you can't do like a partial read of a chunk or a write of a chunk, right? It's all
Yeah, yeah,
okay.
that's a small size you can read or write. So in our case, I don't actually need to. That's why we moved from chunks to simple, because I always will need to read the full data in the file, and we're not in my application need to read just some of it. So I always gonna read it all. So
By simple you mean contiguous data sets?
yeah,
Okay.
yes.
I mean, that's fine. I mean, there's nothing wrong with using contiguous data sets, but it's just when you wanted to have either extendable data sets or compression, then you have to use chunking, right?
Yeah, that's what I'm thinking. So the file size is large, the case is very large, and it's terabytes. So I'm trying to think of ways to reduce the size, and I was thinking to use chunking and compression to do that. So that the purpose is actually just to compress the data.
Right, right. So I mean,
But
it will increase the file size. I mean, the metadata size. So if you use a lot of chunks and your compression is maybe not very good, then it probably will be a large file, larger than maybe even uncompressed. Because if you use a lot of chunks, ridiculous amount of chunks, then that's all metadata that has to get stored in the file as well. And that's not compressed.
Why if I don't use a large number of chunks, maybe just 1 or 2 chunks, and then I compress those? Now the hurt is performance, so that's
Right. Because
my
if you
other
read,
question.
right, because if you go back and read the data set, then if you're unfortunate that your reading expands 2 chunks and is, I mean, more than that chunk you're reading in, then you're going to have to, for your hyperslab selection or something like that, then it's going to have to read that whole chunk, uncompress it, right, and then read it in. It's parallel, it's even worse because it has to uncompress it, read it in, and then it might have to recompress it and then write it again, even though it's not doing anything. So in parallel, if you don't have good chunk set sizes, that can really hurt your performance for just chunking, even without compression. But with compression,
Okay, yeah, I would appreciate if you can send me some maybe documents you have about choosing that right chunk size. What I'm saying is that I could write just one chunk of data. I don't need to use different because I don't have the purpose of reading parts of the file. I will always read it all and write it all.
Mhm.
So I can possibly use one chunk and compress it. So I don't have an idea if this again will need a lot of memory to just write that. The HDF5 will use a lot of memory from the system
It
to be
should
able
just
to do
use
the
the
writing.
amount for your cache chunk size. So once it exceeds the cache chunk size, it's going to write it to disk, right? So
Mhm.
if you have a very small cache chunk size, it's going to go to disk a lot because it's going to have to essentially flush the cache chunk, then read it back in the new chunk. But if you write, I mean, in terms of system memory, if you can increase your cache chunk size, that might help your performance. It depends.
Mhm.
Is that what you're talking about for, you're talking file memory, right? Or what is
No,
in,
I'm not talking about the file size. I'm talking like when I track the memory, the RSS, the max RSS used by, let's say, the Python script I wrote to do the
Mhm.
chunking and compression, and I used auto chunking. I can see it takes more time, maybe like 15 minutes compared to writing in the other one in less than few seconds. And then the memory increases maybe to several megabytes, whereas the other one is just a kilobytes. So
So what happens if you just do, so if you do contiguous, then if you do chunking with no compression, and then chunking with compression, is it the difference between it with compression? I mean, where's the slowdown? Is it in the chunking itself, or is it in when you're doing compression and the chunking?
I haven't tested that. I was trying to do compression with that chunking, but that cannot be done. But I haven't tried the other way around to just do chunking without compression to compare and see.
Right, because I don't know how much overhead chunking is gonna, I mean, compression.
Mm-hmm. Mm-hmm.
So wait,
Yeah,
what
but
does your file look like? What is your, so you've got a very large file you said, right?
yeah, I'm just using a dummy file. So I have a CGNS file from CFD results, but I just read it and using Python, I can tile it to have a maybe a 100 million kind of number of points or an array or something like that, and try to write that and see.
So how many data
Uh,
sets do you have? I'm not familiar
so
with
bas
CGNS layout.
so basically I have, let's say I have 9 million arrays multiplied by 5, and then I multiply those by maybe 20 times. So I get sometimes like about 100 million data points array, numpy float array, you would say.
But how many data sets do you have?
Oh, I'm just testing with a one data set
So
for
you have
now.
one data set in the file.
Yeah,
So the
I'm
amount of
just,
metadata that you have, I mean, if you have a chunked data set, if you make the chunk small, yes, you'll have a bunch of metadata, and that will go into the metadata cache and hang around and make your size larger. Like, I'm not surprised that if you're opening a file, a chunked file, a file with a chunk data set in it, and you're reading from the chunk data set, you're gonna have the chunk cache, which is a megabyte. And then, so and if you're just reading it all in, then if you want to read
So
it in one spot, the chunk
my
cache.
test is, yeah, my tests are all now just for writing. I haven't tried reading that yet. So I'm just testing writing a compressed. So the problem again, so I have a large amount of data that takes a lot of disk size as a file size when you write it in a continuous
But reading or writing
form.
is still going to use the caches, right? Like, so we have a metadata cache, and the metadata cache is kind of a central unit of an HDF5 file. So when you write something out to the disk, right, some metadata, like a chunk B tree or something like that, then it goes through the cache. The cache is not some auxiliary thing that hangs on the side. It's an integral part of reading and writing from files. It's all done through the cache. So when you're writing that stuff out, but those things hang out in the cache, just in case it needs to get stuff from them in the future. So you're going to have a cache that's full of metadata. And yes, you will have several megabytes for that file.
Yeah, that explains it. Yeah. So when you use a chunking, usually, yeah, I noticed that. Okay.
But
that
if
size
you're writing something out, like if you're always going to read the entire data set into memory, then just use the single chunk layout.
Yeah, that's actually what we were using in the past, just a one single chunk size, but still that takes a lot of memory hanging out.
You can set the, I mean, if you care about that 1 megabyte, if that's really a big deal for you, you can set the chunk cache size to 0.
No, I'm not talking about megabytes. Maybe that's the file I'm testing with is still small, but I mean, it takes a lot. In one point, that was 2 years ago or something. The program couldn't continue because after a few writes with the HDF5, the memory was like held by the HDF5 was large, so due to the writing, so gigabytes. I mean,
which version are you using? Because there might have been a memory link in HDF5.
1.8 point maybe 2 or 3. Well, I guess it is an old one. Let me check exactly. But it's like an old one. It's a 2012 one or 2013.
I want to try something new, but most of the memory leaks that we fixed are small, and you'd have to have something active for a long time to leak that much memory.
Yeah.
I mean, sometimes people think that they're using a lot of memory, and it's because of the way that Linux memory allocation works, or any memory allocation, that the process is not going to generally give stuff back to the operating system.
I mean, the problem is if you use a one chunk size for the whole data set, then the compression is going to also read in a terabyte full of data, right? So it's going to use up in memory probably whatever size it's reading in of that whole data set. That's why it's interesting what the difference in memory would be for just doing chunking without compression and then turning on compression, just to see where the memory is actually getting used up. I would be surprised if it's just chunking that would use up a lot of memory.
Yeah, so I don't have a good memory about what happened like exactly that 2 years, but I would say the version we're using is first is 1.8.9, and at that point there were different things. So we were using C++ kind of APIs, and we were using chunking but without compression actually. And at that point, what I found is that taking a lot of memory. Some of it was actually also the C++ APIs. Sometimes, although you close them, it seems like there was a problem with closing those. They may not release the pointers or something like that, or the memory they are using. So that might be one of the issues there. But then the whole story was, the cache memory or the memory were increasing every write, and it doesn't get freed up a lot that exceeded maybe a 2 gigabytes kind of per node that we had at that point with the data we had. So we were trying to increase the size of our H5 files to add more data, and that was not possible. The only way was to switch to that simple kind of data sets and get rid of the chunks, and also use the C APIs instead of C++ APIs.
I would definitely use a newer version of HDF5. We've also changed the C++ wrappers significantly if you wanted to use those, although those aren't as well loved as the C library. Although if you really want to use C++, you can try using one of the header only implementations.
Mm-hmm. Okay. Yeah. Okay. I guess thank you so much. I'll continue testing and see how that goes and see what is the best for our application to use. I mean,
are you discussing this on the forum?
no,
No.
I just sent to Scott an email.
That's a good place to write to comment, and then people will jump in there. You might try the forum. Create a post there.
Sure.
Yeah, I would definitely try a newer version of HDF5.
Yeah, definitely.
You could try page buffering, which might help.
Okay. Thank you.
It doesn't work in parallel, but in serial it should. Yeah, I was going to say, there's a lot of tricky things about chunking that you can tune.
But if you're just looking, if you're basically going to read all the data in and process it, then you can probably just use a single chunk to get the advantages of compression if you need it. And then you don't have to worry as much about pathological cases, because you can get stuff like if you set if you had like very narrow, long chunks in one dimension and then kind of like read in the opposite direction, kind of like it's the same kind of problem if you're trying to like read across like, you know, a row major array in column major order, you just start hitting caching problems. So because the chunk cache is only so big, so you're going to start pathologically ejecting chunks entirely and rereading them back in because you're just reading a few bytes out of every chunk before you move on to the next one. So you can create very pathological cases like that. But in the case where you just want to have you have a data set and you're not doing any partial IO, where you're just kind of like looking at subsets of the data set, you just want the whole thing to sniff it into memory, then you don't have to worry about pathological cases. You just set it to be the same, just make one chunk the same size as your data.
Yeah. Yeah.
Your other option, you could do the direct chunk writes too. If you want to essentially bypasses the library and writes directly to the file, the data set, the chunk, the compressed data. So you can compress it and then write that chunk data. You can't do it in parallel, but you can do that in serial and see if that helps.
So what do you mean exactly? So bypass the HDF5 library, you mean?
It uses HDF5 library, but it bypasses a lot of the maybe stuff that slows stuff down.
Yeah, there's special calls that we add to the library because some people have data that's compressed in hardware, and they just want to take a buffer, stick it, a buffer that's the same size that represents a chunk, and they want to put it in the file at a certain location, and have the library just believe you that it's like compressed in a certain way and that's of a certain data type. We originally did this for synchrotrons because they had ASICs that did all the compression, and so they had gzip stuff of a certain integer format, and they were just like, we just want to put it on the file and have your HDF5 file point to it. So you can do that. It's a sharp edge though. It's a very sharp edge tool, so you have to be very careful with it, because if you if you throw data in there that's the wrong size or the wrong data type, whatever, it's just going to be garbled when people try to read it through the normal HDF5 read and write calls. But it allows you to bypass type conversion. It allows you to bypass the filter pipeline, and all of that stuff has some overhead.
Yeah, and all the B tree stuff for the all that be all bypassed. It will help private formats. I mean, you're essentially writing directly to disk compressed data. I mean, it's probably the most optimal way you can write within HDF5 if performance is your real issue.
Yeah, maybe have to think if you can do that in a code that is running like a CFD code that is running. You can do it on the fly and then write it. I'm not sure, or maybe you can gzip it in another format on disk and then have another call to grab it and put it in H5 file. I'm not sure.
And the thing to remember is that what you're really doing is we're shifting the responsibility for some of that stuff onto you, right? So you have to make sure that that's all correct, because if you mess it up in your code, then the file will not contain usable data. So you have to, it's a, like I said, it's a sharp edge tool. You have to be careful with it. You can get performance gains from it, but you have to be careful. Kind of the philosophy of C, I guess.
Yeah, and that takes me to the last question, Scott. So the HDF5 compression branch for CGNS will be using chunking for compression, I guess. So is the design going to be to have the user decide for CGNS what chunk sizes to use, or?
Yeah, you can set that. If you look at the example, let me see.
So I guess from your, I'm just thinking, so from your like answers, so it seems like the largest problem with chunks is the metadata. So the metadata that are held by the memory, and it keeps
It could be,
increasing.
but if you just have one data set, it probably won't. I mean, the CGNS, it's just one. I mean, you can make it as big as you want. So
Yeah,
how you
the-
control
The metadata is very minimal for if you just have one chunk, because like every data set is going to have inside the file, it's going to have an object header. And then for a chunk data set, it's going to have a chunk index, but that chunk index is really, I mean, like if you're using a version 2 B tree, you're going to have the root, and that's it. So it's just one extra piece of metadata that's fairly small. I mean,
You could
yeah,
have 10 data sets and you do multiple writes. So
right, but that's like that shouldn't be that bad. I mean, if you have if it's 10 data sets and each one is one giant chunk, the amount what's in the metadata cache is gonna be fairly small. It's gonna be 10, it'll be 10 object header pieces, and then it'll be 10 roots of B tree node roots, or extensible array roots or whatever. So it's not a lot in terms of like what you have. I mean, yeah, I mean maybe you've got some writes are going to be to random parts of the disk or storage, but it shouldn't be that. I'd be really surprised if that was your limiting your overhead. Especially, I mean, if you're just writing through that, right? Like, I mean, most of that's going to be, I mean, we have a cache, right? So a lot of those things are going to go to the cache, and maybe they don't get spilled out right away. So it's not even touching the disk. It's just going into memory and saying, hey, updating the size of this thing or how big it is and where it is.
Yeah, it's probably the compression that's doing the memory issue.
Yeah.
But in CGNS, so we have this chunk. It's all handled through CG_configure. And so this sets the chunk size. So this is the number of size of that array, and then you have the count. So in this example, this isn't the tests. So it's test chunk test chunked compression.
Mhm.
This sets the whole this sets the entire data set as
Okay.
chunked. And then you select this. For this example, it uses ZFP, which is an external filter. And then you set the parameters of that filter. That's for ZFP. If you use like the internal ones, you can give it there's a definition for example, the gzip or szip. And then you give it the parameters at that. For this, it's 10. So it has I think this was gzip. So that's how you select your compression or the filter that you want to use. And you do CG filter if you want to set that filter then. And then when you write your coordinates, for example, those will all be compressed. And then you can turn off compression if you want to not do another data set that you don't want compressed. Then you just set that to 0. You set CG set filter to 0 to none, and that will turn off all the filters or the chunking. So the next data set will be contiguous.
Mhm. Okay.
That's how you
I wonder.
handle it in CGNS.
I wonder. Yeah, I wonder for this CGNS compressed if the post-processing tools that we usually have, like PairView or other, kind of finite element kind of post-processing tools will be able to decompress automatically or when they read the
Yes,
CGNS file in that sense.
they should be able to because it's just an HDF5 file. So as long as they have access to that filter, it should be able to decompress it.
Okay.
Yeah, you don't have to do anything special. It'll know. I mean, we store the filter pipeline in there.
Right. But if you use an external filter like ZFP, then they have to have that ZFP in their path.
Right.
And dynamically load it. So
That's
that's the only issue. But other than that, they should, I mean, they shouldn't have an issue. I don't even think they have to update. If you look at the reading the CGNS file, there's nothing about filters in here.
Okay.
So it writes it all, and then it turns off all the filters and the chunking, and then it reads it back. So if you look at the read, let me make sure I'm not lying here. It's been a while since I wrote. Yeah, there's nothing filter unique when reading the data back in, so you shouldn't have any problem.
Okay,
Now,
great.
another thing you could do is, like, I mean, if you're really concerned about performance, the right thing to do is to profile this. You can really easily build the HDF5 library with profiling as a configure action for it. And then build CGNS with profiling, the same profiling flags and whatever your application is, and then just try it and see where the thing's spending time. If it's spending time, it should be in the HDF5 library, you should see it's spending most of its time, you know, in like the dataset IO calls, doing the actual dataset IO. And if it's not, if it's spending its time doing some other stuff like screwing around in property lists or something like that, then that, first of all, that's something we're interested in. So we would really like to see that in the forums so that we can address that. But it may also be that you're doing something wrong in your code, or that the library's CGNS is doing something weird, or
Sure.
profiling is going to definitively answer your question instead of guessing.
Yeah, definitely you update to the newer HDF5 versions, just so we don't not backtracking,
Right.
debugging old versions.
Especially since
Yeah.
1.8 is going to be retired. You want to do like 110 or 113, which will become 114.
Sure. Yeah. I think we should do that. It is just that I'm not the person who manages these things, so I just was looking into what we have, and I guess we should update that. That would have some performance gains for us. So we have even the CGNS library is very old as well. So both of them are, I think the CGNS 3.2. We now have 4 point something.
Yeah, it's really old. There's been especially you don't want to use that non-parallel. If you're using CGNS in parallel, you'll definitely want to use the newer versions. Don't use, you wouldn't want to use the old versions in parallel.
We are serial for now. I mean, the processor 0 writes everything.
Oh, okay.
That's the approach. We write one file, but I guess for the applications we are ahead of, it would be a good idea to write CGNS files in parallel. Even if we can do multiple files, not just one file written. I mean, we can split our file into multiple. That would be good as well, if the file is very large in size.
Yeah, if you want to try, I have subfiling. Subfiling is where in parallel you can write, each node writes its own file. So you'll have as many files. You can write actually more than one file per node on a supercomputer, and then that helps performance a lot. So instead of having a single shared file in parallel, which I mean at the exascale is probably not going to be that performant. So instead you can write subfiles, and then if you decide to, you can put those subfiles back together into a valid HDF5 file, either during your run or post-process those files, the subfiles.
Yeah. I have seen this presentation. Yeah, it is a very good idea, and I guess it's what we need going to exascale. Yeah, if you run in thousands and thousands of processors, you don't want to write in one file.
No.
And at the same time, you don't want to write 60,000 files. So maybe a smaller number could be good.
Right, and if you want to play with the, I guess the other issue is that subfiling doesn't work. It has to be collective, and
Yeah.
subfiling doesn't work with collective right now. So you
Okay. Yeah, I
you
know
could just-
parallel IO has to be collective, although I haven't tried it, but yeah.
yeah, well, I mean,
But we can do this, the idea like internally. I mean, I'm not sure. I mean, if we can, I mean, I guess if we are gonna send the information to every processor to write subfiles, then we may not need parallel IO at that point. I mean, we can do it, like I would say, manually. I mean, each processor writes other 10 processor data or something.
I mean, that's what subfiling is kind of doing. It's
Yeah.
aggregating right on a node, and then one rank is writing a file. So it's doing essentially the same thing ish.
Hmm.
Except it's going to have a valid HDF5 file if you put them back together.
Yeah.
So let us know if you can maybe keep us updated on the forum posts about some of those tests that we mentioned. For example, checking with and without compression, chunking. But but do all that with the newer HDF5 version, and then we'd be interested to see what results. If it's something on our end we have to improve, we'd like to know that.
Sure. Thank you so much. I appreciate it.
Mm-hmm. I guess that's it.
Yeah, unless you really want to talk about anything else, Scott, we can wrap
No,
it up.
okay.
Yeah, but Scott will be back next month this time. And again, for anyone, feel free to post on the forum, because a lot of times the dialogue that happens is helpful to other people, and we get people chiming in that aren't from the HDF group too. So really useful. So that's all I have. Thanks, everyone.
Great.
Bye. Bye all.